Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 12 Physical Sciences exam prep of electric circuits. The question paper we are looking at today is the Department of Basic Education's May-June examinations Physical Sciences paper 1 of 2025. So, let's see. This question is 23 marks. We must finish it within 23 minutes. But for this video, it must be 24. But let's see how far we can go. Let's see. In the circuit diagram below, let me zoom it. In the circuit diagram below, the battery has an amp of 24 volts, an internal resistance of 0.3 ohms. Light bulb L has a resistance of 9.5 ohms, and R is a resistor of unknown resistance. Ignore the resistance of the ammeters and the connecting wires. Okay, cool. 8.1, state Ohm's law in words. Okay, potential difference in a conductor is directly proportional. Let's see. Potential difference in a conductor is directly proportional. That's what we said. It's directly proportional to the current in the conductor provided temperature remains constant or at constant temperature. Depends. Or it's up to you what you want to say. So we say potential difference is a potential difference in the conductor is directly proportional to the current in the conductor. Okay, you can say provided that temperature remains constant. Provided temperature remains constant. Or you can say to the current in the conductor at constant temperature. Provided temperature remains constant. Okay, perfect. When both switches S1 and S2 are closed, the reading on the ammeter A1, where is it? Okay, I see the reading on ammeter A1 is 0.8 amperes. Okay, I don't know how it's going to help us, but let's see. Calculate the current through light bulb B. Are you guys hearing this? The current through light bulb B. So, what we need is this. What we know, I want you to look at the 13 ohm resistor and the 9.5 ohm resistor, which is the light bulb. These two are connected in parallel. So we can say the potential difference of both of them is the same. Okay? So I will say potential difference of L is equal to potential difference of the 13 ohms. Okay? We know R equals V over I, and therefore we can say V equals I times R. Okay? Perfect. Let's see. So here we will say, this says to us, we can say 9, you can write these before you write these, okay? Nothing wrong with that. Now we can say, what we have here, we have 9.5 multiplied by, they said we must calculate the current through bulb L. So 9.5 multiplied by I sub L, okay, equals, on the 13 volts, what is the current? They said the current there is 0.8, so we can say 0.8 times. What is the resistance? It's 13. All right, the resistance there is 13. Right, the resistance there is 13. Now, we have our current. Okay, now we have our current. So this is 0.8 times 13 all over 9.5. What is our current? Our current is simply current flowing at light bulb L is 1,09 amperes. As simple as that. Right? 1,09 amperes. Now we are good to go. Let's go to the next question. 8.2.2. Remember, we have to be done in 24 minutes. 8.2.2. The reading on ammeter A2. What is it? The reading on ammeter A2, let's see, will be 8. Okay, here is it. A2 is the total current, right? A2 is the total current. So we need, I want you guys to hear me out. We need total ohms, okay? We need total ohms, or if not total ohms, at least let's get the potential difference at, what is this? Potential difference at, maybe potential difference V. Maybe let's get potential difference V. Okay, so what we can do now is this. Let's try to find the potential difference of these guys first, and then we will also need another one of this guy. But for now, let's find the potential difference of these guys. We will need to find this RP. So let's go. 1 over R sub P equals 1 over R sub 1 plus 1 over R sub 2. So this is 1 over R sub 1 equals 1 over 9,5 plus 1 over 13. So what is this becoming? Let's see. Oh boy, this is messy. 9,5. So 1 over 9,5 plus 1 over 13. Okay, cool. So 1 over R sub P is now 45 over 247, right? So your calculator is displaying 45 over 247. Just say 1 divided by answer, meaning RP equals 247 over 45. Now this, we will say R sub P equals, let me say, 5,48889. 5 decimal places would do for now, okay? 5 decimal places would do for now. Okay, we're not done. So R sub P equals 5,48889. Now, we are not done. What we can do now, something that you and I know, okay? Something that you and I know. Remember, we calculated current flowing through 9.5. So we will say this. This is the first parallel. So we'll say current through 9.5 and A1. We will say it is 0,8 plus the one we calculated was 1,09 plus 1,09. So what is this? It is 1,89 amperes. This is the current that's flowing here. Of course, there will be another current flowing this way. Okay? Now, we can say, okay, we have an idea. What we can say now is this. We can say, to know the potential difference here, right? To know the potential difference here, I need you guys to be careful here. We are looking for current flowing on ammeter A2. Okay, now to know that current, so far we do not know the current that's flowing to this terminal. So rather, we do this. We compare the voltages of the two, which are equal. Okay, I will say voltage V will be equal to voltage at, I'm gonna say voltage at 9,5 and voltage at 13, so to say, because these are parallel, right? Because these are parallel. Okay, now, good thing we know the total current flowing here, right? So while we are on it, what we know R equals V over I, implying V equals R times I. So we are good to go. All right, we are good to go. Remember, we are looking for the current flowing on ammeter A2. So can we proceed now? All right, can we proceed? Are you guys sure? But let's see. So since we're saying we know the total thing, we know the total current here, we can use the total resistance here to find the V, which is the total potential difference here, right? But the question will then be, can that assist us? All right, can that assist us? So no, let's try this now. Let's see now. What we're gonna do is we will say, comparing these two, right? Comparing these two, we'll then say V equals V at 9,5 plus 13. Let's go. So here, the current flowing there at the 9 ohm, we do not know it, all right? But we know the resistance is 9. The current flowing on this terminal, we have calculated it to be 1,89. And the resistance there was 5.4889, isn't it? Now we can find current flowing on this terminal here, right? We can find this current here, which will be 1,89 multiplied by 5,48889 all over 9. So what is our current? Our current, be careful, our current is 1,1526.7 amperes. Now, current flowing at A2 will be current flowing on the 9 ohms plus current of the 9,5 plus the, what did we call it, plus ammeter A1. All right, so what is this? 1,15 in fact. So it's 1,15267 plus 1,89. Let's see what it is. 1,15267 plus 1,89. What are we getting? We are getting 3,04 amperes, right? So the total current, which is current flowing on ammeter A2, is 3,014. Do you guys see that? We were able to find the current flowing in this terminal and the current flowing in this terminal. So obviously, the sum of them is the current that flew here, right? Perfect. Oh, that flowed there, right? All right, now let's proceed. 8.2.3. See, now this question was quite interesting. 8.2.3, they say we must calculate the resistance of resistor R, right? We must calculate the resistance of resistor R. So to get the resistance of resistor R, wow, it's interesting. What we can do, we can say, no man, let's do this. V load equals nth minus V internal. All right, we already know total current, so we can say this is basically this guy here minus total current multiplied by internal resistance. Remember, internal resistance is given. So what is the nth? It's 24 volts. Total current was 3,04 amperes, and the internal resistance is 0,3. Now we know V load. All right, now we know V load. All right, let's go. So let's see now, what do we do? So we like 24 minus 3,04 multiplied by 0,3 will be, let's see, 23,088, right? 23,088 volts. All right, we're not done. So we then need to know what's happening here. All right, we then need to know what's happening here. To know what's happening here, we know that V load is basically V of resistor R plus V of the what do we call this? Plus V that is flowing here, which will be, let's say, P in total. Okay, let's say P total. Okay, let's say P total. All right. So a question that we should ask ourselves is this: do we know what this V is? Perhaps even if we call it just V, just calling it V because the V here is the same V here. Do we know what this V is? We don't, right? But we know the current, so it's easy, we can find it. So we said this one here is 20, this one here we said it's 23,088, right? 0,88. And this one here is, let's say, total current times resistor R. And this one here, we can say it is, let's say, it is, what is that I? You remember that I? That I was, I can say, okay, V of, yeah. Okay, this V we can basically get it. Yeah, this V we can get it. It is 1,89, no, 1,15267. Let me just do that. 1,15267 multiplied by 9. Then we are done. So let's see. But before I do that, I feel like it'll be so wrong of me. Let me just do this. Let me just say this will be current on the 9 ohm multiplied by resistor R9. Okay, so now let me do it. 23,088 equals I. Resistor R, I do not know you, but I know this I is the total current, which is flowing at A2, which was 3,04, right? And this one here was that one that we said was 1,152, or was it 1,15? Somebody remind me. 1,15267, right? And the resistance that was flowing here was 9 ohms, right? So let's just proceed in that manner. 2,088 equals 3,04 R of resistor R plus, what is this? 1,15267 multiplied by R is 10,37403. All right. So 23,088 minus 10,37403 will be, what is it? It will be 10, oops. Hold on. What is this? Okay. Okay. Okay, what is this? What did I get? I want to make sure that I'm not messing it up. So, okay, perfect. 23,088 minus 10,37403. Aha, I'm getting not 10, I'm getting 12,71397 equals 3,04 resistance of resistor R. This answer divided by 3,04. What am I getting? I am getting the resistance will be 4,18 ohms. Okay, the resistance will be 4,18 ohms. Okay, and this is it. This is what we are getting. All right. So this is your answer, guys. Now let's get to the interesting part of the question. All right, let's see. Oh, remember this was how many marks? It was, oh boy. It was 23 marks. We are now on approaching the 20th. So let's see. Now, let's see. Now, let's see 8.3. Switch S2 is now opened. Do you see this? Switch S2 is now opened. So which one is that? S2 is this one here. Is now opened while S1 remains closed. If S1 remains closed, okay, let's see, current will be flowing. All right. Um, how will this affect the reading on ammeter A2? How will this affect the reading on ammeter A2? Before I answer this question, they say choose from increases, decreases, or remains the same. I will leave a line for increases, decreases, and I'll go to another to say 1. When switch S2 is closed, this will no longer be a parallel combination. It'll be a series combination. All right. So what are you doing? You are removing a resistor in series. When you are removing a resistor in series, that means external resistance is increasing. So here, external resistance is decreasing, not but increasing. All right, is increasing. All right, external resistance is increasing. So resistance is indirectly proportional to current. Therefore, what am I trying to say? I'm trying to say current in ammeter A2 will be increased. Our answer here should be increases, because it seems like it's 2 marks. It seems they want, or because it's 2 marks, it seems they only want one reason. So external resistance is increasing, and resistance is indirectly proportional to current. And we have our marks. Right. Now, let's go to the next one. The next one is 8.4. This one is interesting. How will the brightness of bulb P be affected? Choose from increases, decreases, or remains the same. When you talk about brightness, let me change the color. When you talk about brightness, you need to look at power ratings. VI, V square over R, or I square over R. One of them will be constant, right? So remember, what is happening here? Is that S2 is closed. If S2 is closed, the external resistance is increasing, right? So if the external resistance is increasing, what it means is that V load will be increasing as well, but the current will be decreasing. All right. So let's just answer this question. Once again, I'm going to leave a line to say, they said choose from increases, decreases, or remain the same. It seems they want 3 reasons. How will the brightness of the bulb be affected? First things first, I will leave that line for increases, decreases, or whatever. Then I will say nth is constant, right? And then resistance of the light bulb is constant, right? Then what's going to be happening? External resistance, right? External resistance increases. And then if I'm saying external resistance increases, this means internal potential difference decreases. Or before that, total current decreases. Then if total current decreases, internal resistance decreases, right? And if internal resistance decreases, V load increases, right? Whereas V of R decreases, right? Whereas V of R decreases. Now, look at the formulas I gave you. Resistance of this bulb is the same. So, what we can relate it with will be using this formula here, the power rating formula that is to do with voltage and resistance. So we will then say, okay, if that's the case, then power is directly proportional to this guy here. So obviously, what we are saying, maybe I should also add before I come to this, that if I am saying this, I should also be saying that no, it seems V on the L will be increasing, right? Will be increasing. And we know power is directly proportional to V squared. Therefore, if V of L increases, we must therefore say the simple answer here will be brightness will increase. Okay, brightness will increase. I know it's a lot of things here. This is because the circuit on its own had a lot of things, right? This circuit had a lot of things, right? So you guys got it. Oh yeah. Okay, moving on. Okay, moving on now. Let's see what we can do. This is the last question. The letters A to F represent different quantities in the circuit as shown in the table below. Switch S1 is now opened while switch S2 is closed. Ooh, guys, remember switch S1. Yes, switch S1 is closed. Okay, let's see this. And this is 9.08, not 9. So this is 8.5. Well, write down the letters of the quantities that will be equal to 0. Okay, when the switch S1 is closed, which quantities will be equal to 0? Voltage across the battery, never. A cannot be, right? So we'll say this: A, B, C, D, E, F. Let's see this. A voltage across the battery, nope. Internal resistance of the battery, come on, it'll always be whatever it is. Okay, and then current through ammeter A1. If switch S1 is closed, there is no current that will be flowing basically. So yes. And then let's look at D. Current through ammeter A2. Yes, because there is no current flowing. When S1 is open, there is no current flowing in the circuit. Let's look at E. Resistance of resistor R. Come on, resistance will always be there. Okay, so we can't talk about it. Potential difference across the 9 ohm resistor, what will it be? Of course, it'll be 0. All right? Of course, it'll be 0. So our answer here is C, D, and F. Remember, it's because when S1 is opened, there is no current flowing in the circuit. Remember, for you to say current flowing, yes, current is moving like this, but it will not be draining again on the negative terminal. All right? It will not be draining again on the negative terminal. So current is not flowing. So it bounces back, which is to say not flowing. So our answer is C, D, and F. Okay. And this is it, guys. This is how you attempt this question. All right. All right. Bye-bye.